Welcome back, everybody. Today I'm going to talk about logarithmic functions. Before I begin, let's recall the definition of a one-to-one function. A function is considered one-to-one if it passes through the horizontal line test. Exponential functions are one-to-one functions, which means that an exponential function has an inverse, and its inverse is the logarithmic function. Let's begin by looking at this graph right here of some exponential function and its inverse. The graph g of x increases infinitely in the positive x direction. Here we have g of x is equal to 2 to the power of x. Recall also, for a function to have an inverse, it must reflect on the linear function y equals x, which is a diagonal imaginary line that goes through the graph. And on the right here we have h of x, the inverse of the exponential function, and h of x is equal to log base 2 of x. You can think of a logarithm as a mathematical operation in which some specific number called the base, which in this case here it's 2, is multiplied by itself x amount of times to reach, well, I would say y amount of times to reach this specific number, which is x. For instance, I'm gonna move this here. Actually, before I do the first example, let's look at this expression right here. We have log base b of x. Now, if you're given an expression like this, one way you could solve this is that you can equate this whole expression to y, and then there's a rule that says if you raise b to the power of y, that's gonna give you x. So basically, its exponential reasoning would be b to the power of y equals x. This is a very important concept that you want to keep in mind as we progress throughout this series of videos. But we also have the properties here in front of us. We have log base b of 1 equals 0. And along on the right side here, we have all the exponential reasonings for this logarithmic, these set of properties. And then, so if log base b of 1 is equal to 0, if we raise b to the power of 0, that's going to give us 1. Well, if you raise anything to the power of 0, that's just going to give us 1. Number 2 here, we have log base b of b, and that's going to give us 1. Because if you raise b to the power of 1, that's just going to give us b. So logically, this would mean that the base and the number here have to be the same in order to get 1. Number 3, we have log base b of b to the power of x, and that's all equal to x. Now we know, looking at property number 2, log base b of b, since both values are the same, that's just gonna give us 1. So the x is gonna like drop down here. So logically, this is saying that x is equal to x, which is correct. Now, if log b of x is equal to log b of y, since the bases are the same, which is b, we can say that x is equal to y. Now we're gonna go ahead and look at some examples here. I'm gonna get into this in another video, but for the sake of time, let's look at our first example here. We have log base 2 of 16. Now, how do we solve this? We said that it's easy to equate this to some value, let's say, or some variable, excuse me, let's say x, and that's going to give us 2 to the power of x is equal to 16. Now, what number how many times do I need to multiply 2 by itself to get 16? Well, one thing you can do is, you can just write it out. We have 2 times 2 times 2 times 2. 2 times 2 is 4, and then we have another 2 times 2, which is 4. 4 times 4 is 16. So that's just going to give us 16. Notice we multiply 2 by itself 4 times. Therefore, x is equal to 4. And that's our answer. Another problem here, we have log base 2 of 32. We can straight away just equate this to x. We have 2 to the power of x is equal to 32. Now, how many times do I need to multiply 2 by itself to get 32? Now, we can go 1, 2, 3, 4. We already concluded that that's 16, correct? Now, if we multiply 16 again by 2, we're going to end up with 5 2's. This means that x this time is equal to 5. Another problem. Say we have the log of 1 over 8 base 2. Now, just because you have a fraction doesn't mean the way you solve this changes. However, you shouldn't freak out or get scared when you encounter problems like this. It's really the same way. So 2 to the power of x is going to give you 1 over 8. Now, when you get something like this, one thing you want to do is that you want to make the bases the same. You want to make 1 over 8 equal to 2. So what can you do here? Well, we know that 1 over 8 is 1 over 8 to the power of 1. It's just 1 over 8 to the power of 1. Like nothing's changed. However, if I flip this fraction, so if I flip this fraction, I'm going to end up with 8 to the power of negative 1, because 8 to the power of negative 1 is 1 over 8. So our first step here, at least we got rid of the fraction. We have 8 to the power of negative 1, and we have a power. Now, is there a way where we can change 8 and make it a base of 2 so that we can have the same base and then ultimately equate the powers? Well, yes. 2 times 2 times 2 is going to give you 8. If you multiply 2 by itself 3 times, that's going to give you 8. So since we have 2 here to the power of 3, and then let's not forget this was all to the power of negative 1 in the first place, we're going to end up eventually multiplying negative 1 by 3, and that's going to give us 2 to the power of x is equal to 2 to the power of negative 3. We did all of this just so that we can have the same base. If we end up having the same base and we have powers, we can equate the powers. So in this case, since the bases are the same, the powers are equal. X is equal to negative 3. Let's do one more problem. Here we have the log base 10 of 1 over 1,000. Now, straight ahead, we're just going to equate this to x. We're going to get 10 is equal 10 to the power of x is equal to 1 over 1,000. Now this looks like exactly the problem that we did before. What can I do here in order to make this fraction, or this term right here, the same base as 10? Or how can I make this 10 to the power of something? Well, we know 1000 is just 10 to the power of 3. Okay. Now what are we going to do? We're going to flip this fraction so that we get 10 to the power of -3. The 10 to the power of x on the other side is still there. And now we have the same base. Since we have the same base, the powers can be equal to each other. Therefore, x is also equal to -3. Thank you so much for watching. I hope this was, I know this topic can get a little bit difficult for some of you guys, but it really is straightforward. If you follow those properties, if you commit them to memory, I promise you're gonna be fine. Please don't forget to like this video, subscribe to my channel. This is gonna help the channel grow more. In the next part of this series, I'm going to go over the natural logarithms. But please feel free to leave a comment in the comment section below if you have any questions or concerns, and we'll see you in the next video.